Chapter 16, Practice B, Superposition, Problem number 2, Part A. Now you're going to have to do B and C on your own. So it says 4 charged particles are placed so that each particle is at the corner of a square. So first of all, before you do anything else, you're going to have to draw a picture. Okay? So what I'm going to do is I'm just going to kind of freehand. Here's my square. And I have 4 charges at each end. Now, I have yet to know which is positive or negative or anything else. Okay? And in physics, the best way to conceptualize a problem is not to do it in your head, is to do it on paper and write it down. The sides of the square are 15 centimeters. So I know that each one of these is 15 centimeters. So in my given, I'm going to write away that R is equal to 15 centimeters. And I know that the standard unit is meters. So right away I'm going to convert that to 0.5 meters. And they're all the same because it's a square. So I know this is 15, this is 15, this is 15, and that is 15. It says the charge in the upper left, so this is the upper left, is positive 3 microcoulombs. So what I need to do is I need to start numbering the charges. So I'm going to call this one Q1. And it's positive, so I'm going to put a positive there. So Q1 is equal to positive 3 microcoulombs. Now right away I see this has a prefix micro. Micro is 10 to the negative 6. So before I even go on, just so I don't make a mistake, and remember you're going to need to know this prefix for the test, because anytime we use a prefix in class you're responsible for it, not only on this test but then every subsequent test the rest of the year. So this is equal to plus 3.0 times 10 to the negative 6 coulombs. Then it says Q2 is equal to Q2, the charge in the upper right corner is minus 6. So this one I'm going to call Q2. This is negative. So Q2 is equal to negative 6.0 microcoulombs, which is negative 6.0 times 10 to the negative 6 coulombs. The charge in the lower left is negative 2.4, so this is the lower left. I'm going to call this Q3. And if you want, you can just write it up here, 3.0 micro, minus 6.0 micro, minus 2.4 micro. So Q3 is equal to negative 2.4 microcoulombs, which is negative 2.4 times 10 to the negative 6 coulombs. And the charge in the lower right is negative, so I'm going to call this one Q4. And that's going to be equal to negative 9 microcoulombs, which is negative 9 times 10 to the negative 6 coulombs. So all I did so far is I drew my picture. I established calling each charge a specific number, because that's going to help me with the math, that I don't mix them up. And then I wrote all their values, and I went ahead and I put in the prefixes and did all my conversions ahead of time before I do anything else. Now the distance between all of these, so if this is Q1, Q2, I can figure out the distances. Now, what is the question? It says, what is the net electric force on the 3 coulomb charge? So this is the 3 coulomb charge. So now I'm going to say to myself, what is the next force? So what I'm going to do is I'm just going to draw myself a little picture here. Here's my charge here. And now I'm going to draw a picture and say, what are all the forces that are acting on this? Okay, what are all the forces acting on this? Well, there's an electrostatic force that exists between this one and this one. So that force, I'm going to call that force F13 because that's the force between Q1 and Q3. Then I have the force that exists between Q1 and Q2, so I'm going to call that one F12. And we also see that the force goes from the positive to the negative, the direction. And then the last force is going to be like this, and I'm going to call this force F14. Now, remember, what I'm going to be using over and over and over again is I'm going to be using Coulomb's law. So Coulomb's law says that F is equal to K, let's say Q1, Q2 over R squared. So these are different charges, and this is the distance between them. Now, so far, it's easy to see the distance between these two charges is what? 0.15. The distance between these two charges is 0.15. Is the distance between these two charges 0.15? No. So what I'm going to do is, before I do anything else, I'm going to figure out that distance. So R14, and if you look at it, you can see that this is a right triangle. So this is 0.15, this is 0.15, and this is R14. So R14 is equal to the square root of 0.15 meters squared plus 0.15 meters squared. So when I do that on my calculator, it comes out to be 0.21. So R14 is equal to 0.21. So now I have that. I also know that R12 is equal to 0.15, and I know that R13 is equal to 0.15. Now I can get down to using Coulomb's law. So what I need to do is I'm going to calculate this force, and this force, and then I'm going to use the superposition principle. Okay? So first, let's start with F12. So F12 is equal to K, Q1, Q2 over R12 squared. So that's going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times 3.0 times 10 to the negative 6 coulombs times negative 6 times 10 to the negative 6 coulombs divided by 0.15 meters squared. Now, on your calculator, you can do it however you want. 6 EE, well, the 6 is actually, so it's 6 minus EE, 6 minus times 3 EE, 6 minus equals times 9 EE 9 divided by, so when I do all that, I get that F12 is equal to negative 7.2 newtons. So that's my first force. Now I do it 2 more times. So I find F13 is equal to K, Q1, Q3 over R13 squared. So that's 9 times 10 to the 9 Newton meter squared per Coulomb squared times 3.0 times 10 to the negative 6 coulombs times negative 2.4 times negative 6 coulombs divided by 0.15 meters squared. So then when I put all that in my calculator, (2.4 minus EE 6 minus times 3 EE 6 minus times 9 EE 9 equals divided by 0.15 squared equals. So now I get negative 2.9 newtons. Now I'm going to calculate F14. So F14 is equal to K Q1 Q4 over R14 squared. And see how this made it easy? I already had all my values. I already did all my conversions. I had everything in my given. So now I'm just kind of doing the same equation over and over again. So that's equal to 9 times 10 to the 9 Newton meter squared per Coulomb squared times 3.0 times 10 to the negative 6 coulombs times negative 9 times 10 to the negative 6 coulombs, all over 0.12 meters squared. So now when I do this in my calculator, I always start from the right and work my way left for some reason. So 9, change sign, EE 6 minus times 3 EE 6 minus equals times 9 EE 9 equals divided by 0.12 squared equals. So now I get F14 is equal to negative 5.5 newtons. So now I have my three forces. So what I'm going to do is I'm going to make a chart. And with that chart, I'm going to find the horizontal and vertical components of each force. And then I'll add up all my x's and all my y's. All right, so now I'm going to say here's my force, here's going to be Fx, and here's going to be Fy. And if you do it this way, it just makes it a little bit neater. So I'm going to have F12, F13, and I'm going to have F14. Now, if you go back and you remember what they looked like, F12 went like this. So F12, it's all horizontal. It has no vertical component. So F12 is it's pointing in this direction. So because it's pointing in this direction, the direction's important, this is going to be positive 7.2 newtons. So some of you are asking the question, well, why did when I figure it out up here, it came out the negative? And why are you putting positive here? What does a negative sign tell me when I'm figuring out the electrostatic force? A negative sign tells me whether it's a force of attraction or repulsion, remember? Okay, remember that? So this negative sign means that I have two different charges, and the negative sign means it's a force of attraction. So that negative sign just tells me that they're attracting one another. Whereas here, I need to look at my picture up here to see which direction they're going. So I know it's pointing in this direction, so that's going to be positive. That should be a Y. Whoops. This is Y. And it has no Y component, so this is 0. Now I look at F13, because that one's also easy. F13 goes down. So this has no x component, so this is 0. And this is down, which is negative, so this is going to be negative 2.9 newtons. Now the only hard one, and it's not really hard, is F14. So here's F14. Remember, F14 looks like this. And when we have F14, this is F14, you have F14X, and you have F14Y. Now, what type of a triangle is this? If you go back and you look at the picture, this was an isosceles triangle, wasn't it? Because this was 0.14, 0.15, and 0.15. Remember when we found that? If you go back to here, when we found R, these sides were the same. So if it's an isosceles triangle, that means that if this is 90 degrees, the other two angles are 45 degrees. It's a 45, 45, 90 triangle. So in order to find F14X or F14Y, I can say, I can use sine, I can use cosine, I can use tangent. So F14X is equal to 5.5 newtons times the cosine of 45 degrees. Remember that cosine is equal to adjacent over hypotenuse. If I wanted to, I could use sine, okay? Because sine of theta is equal to opposite over hypotenuse. Remember, the hypotenuse is the 5.5 newtons. Now, we did this in the beginning of the year when we did vector resolution, okay? So F14X, I can say 45 cosine times 5.5 equals, and it comes out to be 3.9. Now, if I want, I can do it again, but since it's an isosceles triangle, it's going to be the same thing. But I'll go ahead and write it out. F14Y is 5.5 newtons times the sine of 45 degrees. So this comes out to be also 3.9 newtons. Now, in order to get the direction, I'm going to look at my picture. This goes to the right. According to my sign convention, the right is positive. So the x component is going to be positive 3.9 newtons. F14Y goes down according to my sign convention. Remember, I'm still using my standard Cartesian sign convention that up and to the right is positive. So because this goes down, this is going to be negative 3.9 newtons. So now what I'm going to do is I'm going to add them up. So f of x is going to be 7.2 plus 3.9. So this comes out to be 11.1. And then I'm going to add these up, and this comes out to be negative 6.8 newtons. So, what do I do now? Well, now I have, what happens is I have my x component, and I find my y component. So the first thing I'm going to do is I'm going to draw a picture. I don't do stuff in my head. I just don't start plugging numbers on my calculator, because guess what? That's how I make a mistake. So F14, this is going to be my x component here. This is my y. So remember, the summation of the x's is equal to 11.1, which is positive. And my summation of my y's is equal to negative 6.8 newtons. So now I'll draw that picture. So when I draw that picture, this is where I start. Here's fx, which is 11.1. From the head of this vector, I do the tail of the other. Now this is negative, so negative, according to my sign convention, goes down. Even though I'm doing it freehand, I'm trying to do it to scale. This should actually have been half of that, but maybe I should make it a little longer. Because 6.8 is a little bit kind of like half. So there's my two vectors. Now this seems long and tedious because I'm explaining everything as I go along. Okay? Now, I need to find the resultant. So when you add vectors head to tail, the resultant vector has to have both magnitude and direction. So to find the magnitude from where I start to where I end up, I'm going to draw a line. Remember, the tail is always where I start. The head is always where I end up. So now I have to find the magnitude of this. This is just F1 total. So F1 is going to be the square root of fx squared plus fy squared. I'm just using the Pythagorean theorem. So that's equal to 11.1 squared plus negative 6.8 squared. And then I take the square root. So when I do that on my calculator, it comes out to be 13. But we're not done, because remember, that is just the magnitude. I also need to find the direction. So how do I find the direction of a vector? I always find the direction of the vector from the tail. So here's the tail. So I'm going to find the angle inside the triangle. Okay? And since I have the opposite and I have the adjacent, I'll use tangent. So tan of theta is opposite over adjacent, which is 6.8 newtons over 11.1 newtons. The newtons cancel. So now on my calculator, I say 6.8 divided by 11.1 equals, but that's the tan of the angle, because that comes out to be 0.6126, but I don't want the tan of the angle, I just want the angle. So now on my calculator, I'm going to press second tan, and that's going to be the angle. So the theta is going to be 32 degrees. And what's my final answer going to be? Well, my final answer is going to be F1 total is equal to 13 newtons. And where is this angle? This is 31 degrees or 32 degrees below the positive x-axis. So 13 newtons at 31 degrees below the positive x-axis. And that is my final answer. So to solve this problem, we did stuff we did earlier in the year, adding vectors head to tail, finding the resultant. We have more than, in this case, we had 3 vectors, and that's it. That's how we do these. So it's a little tedious, but it's not difficult, okay? But you just need to follow the steps. That's the great thing about physics. There's never going to be, well, I don't know what to do. You just do it step by step. So I just showed you a systematic way, step by step, how to solve this problem. So if you want to take a shortcut, you don't want to draw your picture, you don't want to draw everything out, because you see I have a lot of pictures here. But the pictures help you to visualize, and that's how you do it.